Grace College of Engineering, Operating System Laboratory. Lab code is 8461. Exercise number 2, System calls of Unix operating system. System calls. Program, first option is program using system call fork. So fork is the one of the system call. In C programming, if we see like this, fork open bracket close bracket means we will tell it as a function or method. Okay, but here in Unix operating system, this is the one of the system call, that is function. Fork is the function or system call. So fork system call is used to create the new child process. Okay, so in operating system we will tell it as a system call. So first one is system call fork, used to create the child process. Executing the process, wait process, exit process. I already typed this exercise. Second exercise, first one. So these are all the header files we have to include. stdio.h, standard input output, standard library.h header file, universal standard header files. Here universal standard variables constants are available in this header file. Has include system or wait header files. So this header files is supported for the wait function. See here wait function is available. Wait function. This wait function will be work properly by using this header file system/wait.header files. So each and every header files will be supported for the particular functions. Standard input output function is supported for the printf statement. Okay, here main function. Main function with two arguments. First argument is argument C, another argument is array variable with a pointer. Asterisk is used to represent the pointer variable. This is the pointer variable. Pointer variable means it holds the address of the another variable. Okay, so the square bracket represent it is a array. This is the array. This we have taken this argument array in the data type of character data type. Here the variable argument C is in the data type of int. Okay, process ID fork. Here we are calling the fork function, that is fork system call. So it will call the system call. It will find out the process ID and assign to the variable PID. If the PID is less than 0 means the fork is failed, that is the new child process creation is failed. Okay, otherwise if the process ID equal to 0 means executing the process is null. Otherwise print the process ID. The process get parent process ID, get process ID. By using the get process ID method, we are getting the process ID. We will run this program. Okay, for running this program we have to go to the terminal. Here we have to type GCC for compilation. If any error is there means it will shows the error. GNU compiler collection exercise 21.c space -o output O. This is the O. Okay, don't mistake it as a 0. This is the O. Next exercise 21. For running this I am giving the command dot slash exercise 21. The process ID, it getting the process ID. The particular process ID is 12535. So next exercise is second exercise. Program using system calls. The system calls are get PID and get PPID, get process ID and get parent process ID. Okay. The program is looking like this. So these are the header files we included. Fork, by using the fork system call we will go to create the new child process. That particular process ID is -1 means fork failed. Otherwise if the particular process ID is equal to 0 means child process is under execution. So the child process ID is getting by the function name of get PID. By using the get PPID, get parent process ID functions, we can get the parent process ID. Otherwise these both conditions are failed. The process ID is not equal to -1, not equal to 0 means this is the parent process. Okay, this is the parent process. So we can get the parent process ID by using the get process ID. Okay, we can execute this process by entering the command GCC exercise 22.c space -o exercise 22./exercise 22. This is the output. Okay, next second exercise. Second exercise, fourth option, program using system call execution. Here the system call is execution. Second, fourth exercise. We include UniSTD, so universal standard. So it is universal. The date is in the format of universal format only. So for that we are declaring the header files unistd.h main function. Using the printf statement, it will print out the statement executing system call displaying the date. So our system call is executing the process /bin/date. So the date is present in the inside the directory bin. The date will be displayed. We will execute this. GCC exercise 24.c -o exercise 24. /. For running I am giving the command as // exercise 2.4. The date will be displayed. Okay. Next exercise is fifth option in the second exercise. Here the system call is wait and exit. So wait system call is used to wait for the particular process. Exit is used to exit from the particular process. It is terminating the process. Okay. We see the program. Wait. Here we are using the exit function to exit from the fork failed. Here the fork is not fork is failed because the process id is equal to -1. Fork is used to create the child process, but the process id is equal to -1 indicates the fork is failed, that is the child process is not created. If the from that we are exiting by using the system call exit. Okay. And wait, another one thing is wait. We are waiting to complete the child process end. Here the condition is process id equal to 0, so child process start. After child process start, it is running till the loop condition is satisfied. After the loop condition is false, it will go to the child process end. Till the child process ends, it is waiting. Okay. Waiting for the parent process end. Waiting for the child process end. After the child process is ended, it will go to the parent process end. So wait and exit. We will run this program on the terminal page. GCC. For compilation, I am giving the command exercise 2. Fifth option in the second exercise. .c -o exercise 2.5 /exercise 2.5. So the output is looking like this. So sixth option in the second exercise, program using system call status. Here we will go to use the status system call. Status of source and s. So file status of fd1 ampersand t. Creating, opening f status and status. So here file status. Here we are using the file status for system call. It shows the status of the file fd1 and ampersand t. This is the header file file control fcntl file control. So these header files is used to create the files, read the files, file copy functions. For all the functions, these header files will be supported. File error, the particular file does not exist. If the file is present, means it will copy the source to the some destination. File 1 from file 1 to file 2, it will be copy the contents. Okay, I'll run this program. GCC exercise 26.c hyphen o exercise 26 dot slash exercise 26. Enter the file. Before that we have to create some file. Okay, I already created one file, so I will give that file name mercy dot text. Source file size, it is copying, it's counting the size of the source file and destination file. Next exercise is 7th option in the second exercise. Here the system calls gets and seek the files. So okay, for searching something, seeking means searching. So reading, writing, string length, it will go to calculate the length of the string by using the string str length. Seeking, line seeking by using the method of lseek. This is the array fd of 0. I'll run this program. gc space exercise 27.c hyphen o exercise 27. Wait. Exercise 27. Okay.